Like off a bell curve, like on the top of the bell curve, like that. That's the standard deviation.
No, standard. That's just the median or the average number, depending on how that bell curve is being set up. Okay, a standard deviation is your average amount that you can be away from the average number.
But still fall in the same category.
But it's considered normal. Okay, so for example, I'm just going to use really general numbers. Let's say, for example, 5'6" is the average height across the entire globe.
Yeah.
Okay, and so that's everybody's height in the world added together divided by the total population of everybody. Okay, and so we got 5'6" somehow. Now, what we do is everybody's height now gets a subtraction and an absolute value from that 5'6". Okay, so if I'm 6 feet tall, I'm a +6, right? If you're 5 feet tall, you're a -6, but we're still going to count that as a 6. That makes sense? You're a distance of 6 away. That makes sense?
That's just standard deviation. 6 would be standard deviation then?
Well, if we were the only two people being compared here, then that would be and that was what we found as normal. What we're actually doing is we're going to take everybody's distance away from the average, add it together and divide it to find a number that is appropriate for you to be away from normal.
And that's standard deviation.
That's the standard deviation number. So let's say we find that the standard deviation number is 2 inches. So that means from 5'4" to 5'8", because 5'6" the middle, so we have 5'4" and 5'8", okay, is the standard range of a minus and a plus away from normal. The average distance from the average, that is the standard deviation.
Standard deviation, okay.
So if you fall between 5'4" and 5'8", you are in a normal range of heights. Okay? But if I happen to be 5'10", I am 2 standard deviations away from normal.
Okay, yeah.
If I'm 5 foot or if I'm 6 feet tall, now suddenly I'm 3 standard deviations away. Okay. So let's use a different example here. Let's say I'm playing a basketball game, and let's say Kobe Bryant or one of the top players, they average 25 points a game. And then you take that average and you take all the games that they've played and you get the points more and points less than they had, and you make an absolute value from it, so you square and square root it, right? You take those numbers, you add them together, you divide by the total number of games that he's played in, and that gives you a plus or minus or a standard deviation, let's say 5 points. So now a range of 20 to 30 points is normal. Now if he scored 40 points,
that's 1 standard deviation.
40 points is actually 5, so 25 to 30, 30 to 35, 35 to 40, he's 3 standard deviations away. Generally what happens is the more standard deviations away from normal, you want to figure out what happened that day that gave you those results, right? Like the person who happens to be 7 feet tall, we want to know what conditions allowed him to be that tall.
So then your standard deviation would be wrong then.
Well, no, it's just your standard deviation. He's the further away that you are from the standard, the more standard deviations you are away from normal, the more of an outlier, the more of the conditions we want to study what happened are, right? So like if Kobe Bryant scored 60 points in a game, right? We want to figure out what did he eat that day? What was it that he did in his training? What were the shots that he took? What was his percentage? We want to analyze more things when you are further away.
Those numbers called? Those outlier numbers.
Those outlier numbers.
Those outlier factors, basically.
Yeah, but you just want to figure out why, so you can repeat those things, right?